Welcome to CIE Math Solutions. In this video, we will discuss how to find the probability of mutually exclusive events. Welcome to another video of CIE Math Solutions. In today's video, we will discuss and recall the definition and illustration of mutually exclusive events. We will also have the probability rule for mutually exclusive events and examples of finding the probability of mutually exclusive events. But before that, let us recall first the basic concepts in probability. Number one, of course, are sample space and events, and mutually exclusive events. The link of these videos are on the description below or on the link above this video. In our previous video, we have already discussed the definition and illustration of mutually exclusive events. So we have mutually exclusive events are events that do not occur at the same time. They are also called as disjoint because they do not contain same elements. If we represent them using a Venn diagram, we will be having two separate circles denoting each event. So A denotes the first event and B denotes the second event. And so probability of A intersection B is equal to 0. The other way of writing it is that A intersection B is actually an empty set. It means that there are no intersections. So no intersections. There's no common element between event A and event B. That means the probability of A intersection B then will be equal to 0. The question now is, how can we find the probability of mutually exclusive events? The probability of the union of two disjoint or mutually exclusive events, it is equal to the sum of the probabilities of the individual events. That is, probability of A or B is equal to probability of A plus probability of B. Again, if you recall in the Venn diagram, the Venn diagram will contain two separate circles, A and B, denoting they are different events and they are not intersecting. So this suggests that the probability of A union B is equal to the probability of A plus probability of B. Now we take note that the probability of A union B is the same as probability of A or B, which is equal to probability of A plus probability of B. So if you see the word or the connector or, that will suggest that you are combining those two events, A and B. So A union B. Now let's have some examples. Example 1. A letter is chosen at random from the English alphabet. What is the probability that the letter chosen is a vowel or a consonant? Now let's take a look first at the letters of the alphabet. Looking at these letters, there are 26 all in all. Now let us highlight the important words in or the keywords in the item. The keywords here are first, vowel, that's the first event, and the second event is getting a consonant. Now looking at the list of the letters, so the vowels are definitely A, E, I, O, and U. There are 5 of them. That suggests that the probability of getting a vowel will be equal to 5 out of 26. The other letters aside from the vowels are consonants. So the probability then of a consonant or getting a consonant will be equal to 21 over 26. To get then the probability of getting a vowel or a consonant, it will then be equal to the probability of getting a vowel plus the probability of getting a consonant. That is 5 over 26 plus 21 over 26, which give us an answer of 26 over 26 or 1. So the probability then of getting a vowel or a consonant is equal to 1. The reason is that if we add the number of vowels and the number of consonants, it's equal to the total number of letters. So it will be 100%. Let's go to example 2. In example 2, a fair 6-sided die is rolled. Find the probability that it shows, the first one, a 4 or a 5. So looking at the numbers on the sides of the die, we have 1, 2, 3, 4, 5, and 6. If we will take a look at the events, we have a 4 or a 5. So we have 4. So the probability then of getting a 4, is equal to 1 only out of 6. And then the probability of getting a 5, definitely there will only be one 5. So probability of 5 is equal to 1 over 6. Now again, the total number of outcomes on a fair 6-sided die is 6. So if we are now finding the probability of getting a 4 or a 5, that means we will be adding the probability of getting a 4 plus the probability of getting a 5. That will be 1 over 6 plus 1 over 6, which will give us 2 over 6, or in simplest form, 1 over 3. The probability then of getting a 4 or a 5 in a single roll of the die is equal to 2 over 6 or 1 over 3. The second item. Find the probability that it shows an even number or an odd number. Again, there are 6 possible outcomes. Even numbers on the die will be 2, 4, and 6. So the probability then of getting an even number is equal to 3 out of 6. The second part will be an odd number. So we have 1, 3, and 5. So the probability of getting an odd number in a single roll of a die is also 3 over 6. Finding then the probability of getting an even or odd will be equal to the probability of getting even plus the probability of getting an odd, which is equal to 3 over 6 plus 3 over 6. Adding these two, we have 6 over 6 or 1. The probability then of getting an even number or an odd number in a single roll of a die is 1. For triple I, a prime number or a number greater than 5. So again, for a prime number, if you recall the definition of a prime number is a number that can only be divided by itself and 1. So for this case then, the prime numbers from 1 to 6 are 2, 3, and 5 only. So in this case then, the probability of getting a prime is equal to 3 over 6. 3 out of 6. The second part is a number greater than 5. So a number greater than 5 will definitely be 6 only. So the probability then of getting a number greater than 5 is equal to 1 over 6. So if you are getting then the probability of getting a prime or a number greater than 5, we will then have to add the two probabilities. So the probability of getting a prime is 3 over 6. The probability of getting a number greater than 5 is 1 over 6. That will give us 4 over 6, or in simplest form, 2 over 3. If you have questions or clarifications about these items that we are discussing, then you may write them down on the comment section below. Let's proceed to example 3. In example 3, a bag contains 3 blue marbles, 5 red marbles, and 4 green marbles. A marble is taken at random from the bag. Find the probability that the marble taken is a red marble or a blue marble. So for I, a red marble or a blue marble. Again, in the bag, there are 3 blue, there are 5 red, and 4 green. We will take a look at each of events first. Probability of a red. So we will just write probability of red. The probability of getting a red definitely will be 1, 2, 3, 4, 5. There are 5 marbles. And if we add all of these marbles in the bag, there are 12 of them. 12 marbles. So the probability then of getting a red will be 5 over 12. The second one will be the probability of getting a blue. If you take a look at the bag, there are only 3 blue marbles. So that will be 3 out of 12. So the probability then of getting a red or blue marble will be equal to 5 over 12, which is the probability of red, plus 3 over 12, which is the probability of getting a blue. Adding these two probabilities will give us 8 over 12. Or, in simplest form, we have 2 over 3. So the probability then of getting a red or a blue from the bag is 8 over 12 or 2 over 3. For double I, a green marble or a red marble. So again, let's take a look at the probability of each of them first. So probability of green. So in the bag, there are 4 green marbles. So we have 4 out of 12. The probability of getting a red, probability of getting a red marble. There are 5 marbles. So we have 5 over 12. So the probability then of getting a green or a red is equal to 4 over 12 plus 5 over 12. That is equal to 9 over 12, which is simplified to 3 over 4. For triple I, getting a blue marble or a green marble. So if we will have the probability of the blue one, that will be equal to 3 out of the 12 marbles. The probability of getting the green, there are only 4 green marbles, so 4 over 12. So the probability then of getting a blue or green is equal to 3 over 12 plus 4 over 12, which gives us 7 over 12. The probability then of getting a blue marble or a green marble is 7 over 12. Again, with all of these examples that we are using, they are all mutually exclusive. If you would like to ask why is it mutually exclusive, looking at the I, for example, a red marble or a blue marble, there is no chance that a marble from the bag is a red and blue at the same time because they are separated per color. The same goes with double I, a green marble or a red marble. They are mutually exclusive because there's no chance that it's a green at the same time red. For the last one also, a blue marble and a green marble. There is no marble in the bag that is blue at the same time green. So they are considered as mutually exclusive events. Let's go to example 4. In example 4, a card is drawn at random from a standard deck of cards. Find the probability that the card drawn is, for I, a red card or a black card. Before we go to the probabilities, let us recall the standard deck of cards. Here is a standard deck of cards. There are 52 cards all in all. So we have 52 cards. For I, a red card or a black card. So we have a probability of red card and then probability of black card. If you take a look at the deck of cards, these are all red on the lower half of the deck. So these will be equal to 26. And this one, for the black one, this will also be 26. If you get now the probability of a red card, that will then be 26 over 52. And the black card is 26 over 52. Getting then the probability of a red or black will be the sum of the two probabilities. Probability of red is 26 over 52 and probability of black is 26 over 52, which gives us 52 over 52 or 1. So the probability then of getting a red or a black is 52 over 52 or 1. For double I, an ace or a face card. So if we take a look again, so probability of ace, if we take a look at the standard deck of cards, there are only 4 aces. 1, 2, 3, 4. So there are 4 out of 52. For the face cards, so probability of a face card. A face card is a card that contains faces. So those are all from Jack, Queen, and King. So we have all of this as face cards. So we have 3, 6, 9, 12. So there are 12 out of 52 cards. The probability then of getting an ace or face card is equal to 4 over 52 plus 12 over 52, which is equal to 16 over 52. If we simplify this further, this will be equal to 8 over 26 or 4 over 13. So the probability then will be 4 over 13 or 8 over 26 or 16 over 52. Now again, if you recall and check, if you would like to check if these two events are mutually exclusive, an ace and face card, just answer the question, is there a possibility that the card is an ace at the same time a face card? If the answer is no, there's no possibility, then they are mutually exclusive. Okay then, let's proceed to triple I. On triple I, a red card or a spade. Let us take a look at the probability of each. So probability of a red card, the lower half are all red. There are 26 of them. So 26 over 52. For a spade, probability of a spade. The shape of the spade is like this. So all of this on this row are all spades. So all on the second row are spades. So if you take a look at the number of spades, so 2, 4, 6, 8, 10, 12, 13. There are 13 spades. So we have 13 over 52. If we will then get the probability of getting a red or spade, that will then be the sum of the two probabilities, 26 over 52 plus 13 over 52. That will give us a probability of 39 over 52. This will then be equal to 3 over 4. So the probability then of getting a red card or a spade will be 3 over 4. Again, if you would like to check if they are really mutually exclusive, the question there is there a chance that the card chosen or picked is a red card at the same time it is a spade? If the answer is no, then that means they are mutually exclusive events. Let's go to example number 5. A number or the numbers 1 to 20 are written on separate flashcards. If a card is chosen at random, find the probability that the number on it is I, the first one, either even or odd. Now let's lay down all the numbers or all the flashcards containing the numbers 1 to 20. Looking at the cards with the numbers in it, so if you will find the probability of an even, you know that even numbers are the 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. There are definitely 10 of them. So we have 10 out of 20. The probability of odd, those are all the numbers that are not encircled. There are also 10 of them. So the probability then of getting an even or odd, that will then be the probability of getting an even plus the probability of getting an odd. So this will then be 10 over 20 plus 10 over 20, which will give us 20 over 20 or 1. The probability then of getting an even or odd will be 1. Now again, if you want to check if they are mutually exclusive, the question there is there a case that if you pick a number from those 20 cards, the number that you pick is even at the same time odd? The answer is no. So if the answer is no, then that means they are mutually exclusive Venns. Let's proceed to double I. On double I, a perfect square or a prime number. Now for the probability of a perfect square. What are perfect squares? Perfect squares are actually the number or the product of a number being multiplied to itself. So for example, we got 1 times 1, a perfect square is 1. 2 times 2, it's 4. 3 times 3, it's 9. 4 times 4, 16. If you multiply 5 times 5, it's 25, but it's not present on the cards anymore. So on these 20 cards that we have, there are only 4 perfect squares out of 20. Next will be the probability of getting a prime. Now let me change the color of my pen. Okay, for this one, for prime numbers are numbers that can be divided only by a number divide by itself and 1. Or the only factors are 1 and itself. So if we will check on the numbers, definitely 2. The only factors of 2 are 1 and 2. No other factors. The same goes with 3. The same goes with 5 and 7. 9 is not, because 1 times 1 and 9, 3 and 3. So there are a lot of factors. There's more than 2. 11. 11 times 1 are the only factors. 13. 1 and 13 are the only factors. Is 15 a prime number? Definitely not. We have 3 times 5, we have 15 times 1. So there are more than 2 of them. More than two factors. 17 is also a prime. 19 is also a prime. Now let's double check. We have 2, 3, 5, 7, 11, 13, 17, and 19. So there are 2, 4, 6, 8. There are only 8 prime numbers. So 8 over 20. So if we are finding then the probability of a perfect square or prime, that will then be 4 over 20 plus 8 over 20, which will give us 12 over 20, or in simplest form, this will be 3 over 5. Again, if you would like to check based on the encircled numbers, there is no chance that they have the same elements. It's a perfect square and prime at the same time. There is no possibility that the number will be both perfect square and prime. Let's go to triple I then. For triple I, a number divisible by 3 or a multiple of 7. So if you will write down the probabilities, so probability that it is divisible by 3, and then the probability that it is a multiple of 7. Now, let's identify first the numbers that are divisible by 3. We have 3, we have 6, 9, 12, 15, 18. So there are 6 of them. So we have 6 over 20. Multiple of 7. Multiple of 7 means that 7 times 1 is 7. That's the first multiple. Followed by 14. No more. The next will be 21. But it's not anymore included on the cards. So that will be 2 out of 20. The probability then of a number taken is a number divisible by 3 or multiple of 7. Multiple of 7. The probability then is equal to 6 over 20 plus 2 over 20, which is equal to 8 over 20. In simplest form, this will then be 2 over 5. So the probability of getting a number divisible by 3 or a multiple of 7 is equal to 2 over 5. I hope all of those examples that we have discussed are clear to you. So if still you have questions or clarifications about these examples that we have discussed, then write them down in the comment section below. I will soon respond to your questions or comments. Now let's go to the homework. For your homework now, give your own example of mutually exclusive events and state the reason why they are mutually exclusive. You can use practical examples. For example, your daily activities. Are there daily activities of yours that are considered mutually exclusive events? You may write your answers in the comment section below. And let me verify if those examples of yours that you have given are really mutually exclusive events. If you are interested of math tutorial videos, you may check on the description below for the playlist of these videos. Or if you're interested on watching math shorts which are maximum of 60 seconds long or 1 minute long, the link is also in the description below or on the link above this video. Or if you would like to visit our blog at www.ciemathsolutions.blogspot.com, there you will see or will find free downloadable materials and study resources for IGCSE Maths, Pure Math, Statistics, Additional Math, and for your own exam preparations. Thank you very much for watching this video. For more videos on math proofs and derivations, math tutorial videos, solve items from international exams, math tricks and puzzles, math resources and more, please don't forget to like, subscribe, and share. Thank you very much for your continued support to CIE Math Solutions.